this little sign I made says movie theater tickets. It's expensive to go to the movies now, isn't it? It's like $12.50 for isn't it? Like $12.50 or something? $10.50? Yeah, man, that's a lot of money. Yeah. All right, so here's what I have for you, right? So general admission for this particular movie theater is $8. If you're a senior, you get a $2 discount. The total revenue, what's revenue mean again? How much they made, right? So the total revenue for Saturday night was $3,580. And the number of tickets sold all night was 525. All right, so the warm-up to get our brains thinking is, what questions could we come up with from this given information? I can think of a few things. So I'd like to know what you think. Okay, I'll take your thoughts. Yes?
How many senior bought tickets to get that revenue?
Okay, how many senior tickets were sold? Okay, good. What else can we talk about? What else? So how many seniors were sold? Anything else along those lines? Yeah, there you go. How many general admissions were sold? Okay, good. All right. Well, what we're gonna do is we're gonna try and answer those questions. Okay, but we need to introduce variables. Right. One of the fun things about math is that you can introduce variables and they can be whatever you want them to be. So what would be an appropriate variable for these two things that we don't know? Right. You want to do X and Y? Really? Okay. Oh, there you go. Let's do that. Right. Let's let G be general, and then let's let S equal senior. All right, that's pretty reasonable, right? G and S. All right, cool. So how can we relate G and S to the number of tickets sold? What do we know? What's the relationship between G, S, and the number of tickets sold? You got it. We know that G plus S has to be 525. Is that true? The total number of tickets, right, the combination of all of those together have to be 525. You guys are with me so far? That's the easy one. All right, what's the more difficult one to come up with? You're close. She says 8G plus 2S is 3,500. She's like 99% there. Yeah, is 2 the cost of the ticket? It's the discount. So rephrase what you just said with the right thing. 8G plus 6S is 3,580. There you go. Is 3,580. There you go, right? Good. Hold on to your answer, okay? Now, this right here, this whole entire thing is called a system. A system of, and in this case, we're only studying linear equations, so equations. It's when you solve 2 or more equations simultaneously. That's called a system. So some systems could have 3 equations, some could have 4, some could have 50. Oh my gosh, I would not want to solve that, right? But it could happen. So when you have 2 or more equations being solved together, we call that a system, all right? And this is the whole first box. What do you guys think about that? We don't have to solve this yet. We're going to come back to it, okay? And we're going to check Brody's answer. So if you had to guess, do you think that'd be more general or more senior?
More senior.
Oh, all right. More senior? Well, we'll come back and check it out later, okay? Yeah, Brody says he figured it out, okay? All right, for the second idea is we're going to talk about the 3 possible ways that you can actually solve a system. So a good question to remind ourselves on the left-hand side is what are the 3 ways that we could solve a system? I'm gonna go with Brody since I know that you took Algebra 1 last year, right? Is that what you did? Because you're doubling up this year? Okay, what's the first way that you can solve a system? Substitution, okay. I'll take that one. What is the second way? Yeah. Elimination. So substitution is one way, elimination is another way, and in fact, we're going to cover both of those ways today. Substitution and elimination. And what's the third way? It's the visual way? Yeah, graphing. There you go. There you go, right? So the 3 ways to solve a system are you can use substitution, elimination, or you can use graphing. And we're actually going to cover a little bit of graphing today, too. Okay, so let me give you a little more content here before we move on. The way that the graphs look tell you a lot. So I'm going to give you 3 pictures here so we can talk about them. Yeah, it's all part of it. All right. 3 outcomes for possible systems, right? Well, one of them could be this one. I could have 2 lines, since I'm talking about linear systems, that go off in both directions, and they actually intersect somewhere. Where they intersect means that there's only one solution possible, because that is the common point of both my red and my blue graph. So I could have one solution, and it's going to be where they intersect, wherever x comma y happens to be. That's easy. That makes a whole lot of sense. That's easy. All right. Hey, what's another possible situation? I know you.
Parallel.
Yeah, they could be parallel. Very good. I could have a blue line, and I could have a red line. 2 of my equations in my system, and they could be parallel. If they're parallel, what does that tell you?
No solution.
Well, okay, why? Why is there no solution? You're right, but what do they tell you? Yeah, there's no solution.
There's no common value.
Yeah, because they never intersect. They have no common value. There's nothing that they share. There's no solution, right? The book calls this an inconsistent system. I'm going to look up how to spell that. I'm not a terrible speller. I-N-C-O-N-S-I-S-T-E-N-T. Is that right? There you go. An inconsistent system. So if there's parallel lines and they never talk to each other, it's inconsistent. We're going to talk a little bit more about that. So far there's one solution. They could be parallel lines. And what's the third way? What do you think? Perpendicular would be one solution, right? They'd mark. Same line, yeah. So it's like if the red line and my other equation were like, right on top of each other, basically the same line. So we would call that infinitely many solutions. And the book is that a dependent system. How many of you guys play sports? Who plays sports? Okay, so what happens when you're the sub? What do? You switch them out. You replace yourself for somebody else, right? Okay, that's the exact same idea here for when you're solving a system by substitution. The trick here is to find the one variable that has the easiest coefficient to deal with. So which one is the easiest coefficient to deal with? 1, right? The y. So what we're going to do is we're going to choose to solve this thing for y. So that means that y would be, if I resolve this, negative 2x plus 5. Do we agree with that? All right, so now I can talk about x in terms of y. I can say anything you want to know about y, just take the x value, multiply it by negative 2 and add 5. That will give you what the y is. So we can talk about x in terms of y and y in terms of x. So now I can take this information, right, and I can actually substitute it in for the only other y in the other equation. You guys have seen this before, right? Yeah. Okay, good. So negative 4x plus 6 times negative 2x plus 5, that's why we're not spending a whole lot of time on it, equals 12. Now we're back in like Algebra 1 land. Awesome. Easy to do, right? So let's do this together. Negative 4x. What's 6 times negative 2x? Minus 12x, what is that, plus 30, equals 12, using the distributive property there. So negative 4, negative 12, how much is that? Like terms? So I got a negative 16x plus 30 equals 12. Okay, what do I do with the 30 now? Subtract it. You guys know exactly what's going on. So is that negative 18? So we'll divide by negative 16. We'll divide negative 16. So x, if I simplify or reduce my fraction to no common denominators, is it 9/8, right? 9/8. 9/8 is like 1.125. Alright, now that I have the x, what do I do with it? Am I done? No, I'm not. I need to go and plug it right back in for my x. So follow the arrow. So then y must be negative 2 times 9/8 plus 5. All right, cool little trick here. Simplify the 2 and the 8. What do you get? 9/4. So y must be negative 9/4 plus, here's another cool trick. Negative 9/4 plus 20/4. How did I do that so fast? Am I a genius? Yes. But what's the trick? You guys know the trick? You good? Good. Multiply those two together and put it over 4. You guys know that, right? Oh, you don't know the trick. Oh, yeah. Just multiply the 2 and put it over whatever. Right? What's the advantage of that? Comes on there, good. So then y must be 20 minus 9 is 11. 11 over 4, sweet. So what is my answer then? My solution to my system has to be 9/8, 11/4. So just for reference, this is approximately 2.75. Is that right? Yeah, 2.75. No, buddy, hang it. 2 more boxes. Okay. Now, on these calculators, we can plug in a system of equations and take a look at the graph and see where they intersect. Here's how you do it. Unfortunately, you have to solve each of your equations for y because we can't put it any other way. So the first one's easy. This is going to be negative 2x plus 5. But I need someone to solve that second one and tell us what it is to put it into the equation. Solve the red part for y. Is it 3/2 x plus 2? Are you sure? I don't know. Okay. Are we going with her? Can someone check it? I think it's 2. I don't know. Is it 2/3? I think it's 2/3. 2/3 x. How much? And then what? Come on. Do the math. All right, we're solving the red equation for y. What do we get? Plus 2. Well, we'll see if we're right in just a second. So we put both of them in terms of y, and now we're going to solve them. So let's hit graph. Oh, mine seems to work out pretty good. All right. Okay. Okay, hit zoom. Sorry, hit zoom 6 so we're all looking at the same picture. If you hit zoom 6, then we all are guaranteed to look at the same picture. Okay, there we go. Good. Now, here's the trick, right? Let's hit second, comma, trace. Second trace, which is that brings us up to the calculate menu. Second trace. All right, now which option are we going to pick, you guys? Yeah, option number 5, intersect. So by pushing enter, it already brings you to the first line. Right? It says, what's the first curve? Well, even though it's a line, call it the curve. So just push enter, and it automatically bumps you to the second curve. And then push enter again. Do you want to guess? No, I don't want to guess. Just tell me what the answer is. Hey, 1.125, comma 2.75. Is that what we got? That's exactly what we got. And take a look at the graph. Does that graph look like a one-solution graph? Yes. Oh, he's clapping. I love it. Yes, very good. Very good. All right. Here we go. Let's go to the last example. We're going to solve by elimination. Nice. Very good. So the original ticket problem said it was 6x plus 8y equals 3. Oh, did I mess that up? Yeah. Is it the other way around? Yeah. Well, it's 8y plus 6x. Okay, let's do g plus s equals 525. Let's just do it the way we have it. Where am I going here? Here we go. Let me erase. Sorry, team. Let's do plus equal 520. And then it was general is 8. 8 general plus 6 senior equals 3,000. Help me out. 580. Cool. All right. Which variable would you like to eliminate? The G or the S? It doesn't matter to me. Whichever one you want. G. S? G? Doesn't matter. let's do this, right? Let's eliminate the g. If we want to eliminate the g, that means we have to multiply the entire equation by the opposite of the coefficient in front of the other g. You got it. -8. So here's what that gives us. That gives us negative 8g minus 8s equals, what's 8 times 525? Help me out. 4,000, 4,000, what? Oh, that's, I should have. Negative, thank you very much. Okay, cool. Now, if we add this, like we would normally add an equation, the 8g goes away. It's been eliminated. All right, so we've care of the g variable. It's been eliminated. This is one of the methods, right? So let's keep adding. What's 6s minus 8s? Negative 2s equals, what's 3580 take away 4200? Negative 620 dividing by 2. Negative equals 310. So there were 10 senior tickets sold. Ooh, he knows. Yes.
There were 215 general tickets.
That's right, because if we add the general plus 310, has to be 520. Did you get it right? Yeah. Oh, cool. The general tickets has to be how much? 215? All right, there you go. Hey man, the seniors are painting the town. We're going for it. Woo-hoo. $2 discount. We're going to the store. All right. Here we go. Last. No, $5 is here. Okay, this is a challenge. Ethan, wake up, buddy. This is a challenge. Okay, most people get this wrong for a specific reason. All right. So once you think you have your system down, go ahead and solve it, and then check to see if you got it right. You can assume the two numbers are positive for this one. So let's talk about the correctness and then the common misconception, okay? Let's keep our variables the same, and let's compare the two, okay? You said, what's your first one?
I said x minus y is 40.
You said x minus y is 40, and then I'm assuming you said the same thing, Olivia? X minus y is 40? Okay, cool. X minus y is 40. So far, we're all good. Now, can you tell me what you said for the second one?
Well, because y is being subtracted, it's got to be smaller.
There you go.
So I did 6y minus x is 5.
Okay, and I'm guessing that, Olivia, did you do 6x minus y is 5? Okay. That has to be. Okay. Yeah, okay. Do you see the difference between the two? Yeah. You guys have something different? That's what you have? You guys had x minus 6y? Equals 5. Okay. Okay, yeah. So notice it's this and this say something that they're pointing to different things, right? Right? In the common misconception, the 6y is negative, but in actuality, it's positive, right? Over here in the 1, because we're going to take 6 times the smaller number less the larger number. So that's what that says. This says 6 times the smaller number less the larger number is 5. That's not what this says. This says the larger number less 6y, the smaller number is 5. You see the difference in the two? They're really, it's all playing with the words, right? So anyways, when you solve this, how did you solve this one, Daniel? Did you use substitution or elimination? So you use substitution. And then and then did you use substitution here? We get x is like 47, and then y is equal to 7, right? So the difference is, if we take the difference of the two, we still get 9 in both cases, or 40, we still get that. But when we do 6 times a smaller number, 6 times 9 gives us 54, less the larger number, 9. That's where the 5 comes into play. Where the other one says, go ahead and go. 6 times the smaller number 7, which is 42, minus the other number, 47, is negative 5. You see the difference between the two now?
It's always going to be phrased like that?
Well, this is just how this is phrased in the book, so I wanted to talk about it. All right.